Okay, so the problem we're going to do today is a problem where we're searching for the initial velocity of the ball, even though in this case it's a ball, soccer ball getting kicked at a goal. Even though we know the horizontal distance, the vertical distance, the angle it's kicked at, we don't know that initial velocity. This is a little more challenging problem. So what I'd like you to do is try to solve it. The data you have is, you know, the x value is 20, you know the y value is 3, you know that the initial velocity we don't know, we know the angle is 10 degrees. Create a data table, try to solve the problem, pause the video now. Okay, welcome back. And so what we're going to do now is we are going to, hopefully you did this already yourself, we're going to set up our data table. So we know that v initial x is equal to the initial velocity times the cosine of theta. In this case, theta is 10, so it would be 10 degrees. You could plug in your calculator cosine 10 and get a decimal. That would be okay. It would definitely not mark that wrong. But you may have a slightly different answer than I get because of rounding. I'm not going to get particular on where you round, but as you're going to see when doing this, if you leave it as cosine 10, and once you know to do this, you'll probably do it. Leave it as cosine 10 when we get further down the problem. It's going to be easier and you're going to have less error in the problem because you're going to combine some terms. Remember that this is the component of x. That would be the component in the x direction. There's going to be a component in the y direction. Those are the x and y components of the velocity, which was kicked in that direction. So VOY, the initial velocity y, v naught y, is equal to v initial times the sine of 10, same thing as the cosine here. AX is equal to 0 meters per second squared. Acceleration in the y direction is equal to negative 9.8 meters per second squared. The displacement in the x direction is 20 meters. Displacement in the y direction is 3 meters. We're going to solve for t. And so when we are taking a look at this, we can see we have 2 known values, but to use the kinematics, we always need 3. So we have to either find a third, or we're going to have to use a system of equations, which is exactly what we're going to have to do in this problem because we don't have any other data. So I would use the equation x is equal to v initial t plus 1/2 at squared. At squared, just like that. And I would write 2 equations, one for x and one for y. The x equation would be 20 is equal to v initial cosine of 10 plus 0 because the acceleration is 0, so that whole term goes to 0. The y value would be 3 is equal to v initial sine theta. There should be a t here. Drop the t. V initial cosine 10t sine theta t minus 4.9, half of 9.8 times t squared. Now, you could solve, the smart idea is to solve for the first equation because it only has one term on the right, where this has 2 terms. That would create some other problems for if you try to solve for t or v initial. So I would use this one. I'd solve for v initial or t. It really doesn't matter. If you solve for v initial, you will have some things cancel out, and you'll have a t and a t squared, and you'll see what happens with that. If you have solved for t and you substitute it in, you have some other things cancel out, but then you'll have a v initial in the denominator. You'll have v initial squared. You'll have to multiply both sides by v initial squared. The advantage of using v initial is that you get the initial velocity right away. The disadvantage of using t is that you get t, and then you have to do another equation to get v initial. So in the end, I think it's about the same amount of time to go both ways. I am going to solve for v initial, but you could solve for t and get the same exact answer. And so what that means for you here is that v initial is equal to 20 divided by the cosine 10 of times t, and then you're going to substitute that in here, and that's it. There's nothing that gets substituted in down there. And so we get 3, if you had to t, it would get substituted in down there. 3 is equal to 20 over cosine 10t times sine 10 t minus 4.9t squared. So at this point, you can start to see the t's cancel out. There's a t here and a t here, they cancel out. And sine over cosine is tangent. So that's why I said hold on to it, because I knew that this was going to end up being tangent. So I get 3 is equal to 20 tangent theta, or tangent 10, minus 4.9t squared. Works out really nice. You have t squared, one variable. You do have a square there, so you're going to take a square root. So you would subtract 20 tangent 10 from both sides. You would divide both sides by negative 4.9. You'll get t. So you would take 3 minus 20 tangent 10 over negative 4.9. Take the square root. That's equal to t. And then once you have t, which you could plug into your calculator and get an answer to, once you have t, then you can use t to find the initial velocity. And the way I would do that is I've already solved this equation up here for initial velocity. So I take whatever answer I got down here, I plug it in for t, get my initial velocity, and be done. We'll come back and we'll try a second problem in a few minutes. Make sure you get the right answers and you work through and you get some numbers for this.